Okay, year 9s, eyes on the front of the board in 5, 4, 3, 2, 1. Thank you to those who are sitting up, ready to begin learning. Still waiting on a couple people up the back. Fantastic. Now, before we begin, this will be a whole class activity. So, for those of you particularly up the back, please raise your hand to indicate you can see the whiteboard. If you cannot, I've got printouts here to assist you in following along on the learning. So we are continuing in our trigonometry topic in learning how we can calculate the known length of a side of a right angled triangle. Who can tell me what a right angled triangle is? Hands up. Yes. Exactly. A triangle that has a right angle on one of its corners. And what is the right angle in degrees? 90. Fantastic. Thank you very much for answering that. 90 degrees. So today's lesson we'll be learning about how we can actually use trigonometry to calculate unknown lengths of a triangle. Our first major step, however, is labelling the sides and choosing the correct ratio. So labelling the sides, there are 3 sides to a triangle. We have our hypotenuse. The hypotenuse is always the longest side and is opposite the right angle. So we'll label that first here. Remember, if you always have a bit of trouble knowing where the right angle is, just label it there. Okay? Little box will indicate that is the right angle. The other side after that is the adjacent, which is the side that connects to the known angle. Now, I should mention the known angle is 65 degrees. Without that knowledge, we can't actually calculate. So it's very important we know that. And the last one is called the opposite. Why would we call it the opposite? Exactly. Yes, because it is the opposite side to the angle. It's opposite the known angle. So, hands up if you're confident in labelling the sides of a triangle. Fantastic. We'll continue moving on. Remember, this is a whole class activity, so we work together. The next part is choosing the correct ratio. Now, can anyone remind me what the 3 trigonometric values are? Yeah, sine. What's the other ones? Cos or cosine, but we'll put cos. And the last one, tan. Fantastic. These are all functions on your calculator. So we use this acronym called SOHCAHTOA. And what that basically means is you have SCT, which are our values here, sine, cos and tan. Then you have OH, AH, OA. What could they possibly mean? Fantastic. Those are the sides of the triangle. So, O is going to equal the opposite. H will equal the hypotenuse. And then A will equal the adjacent. So, an example we'll be going through is we are focusing on the adjacent hypotenuse side. So using that knowledge of SOHCAHTOA, I would like you guys to have a bit of a think and realise which of these 3 values will we be inputting. Yes? No, not tan. Think again. SOHCAHTOA. Yes. Fantastic. Ka. As cos equals the adjacent over hypotenuse. There we are. Just remember, we can always read it out like that. So sine will equal opposite divided by hypotenuse. Cos will equal adjacent divided by hypotenuse. And tan is going to equal opposite divided by adjacent. But we can actually use this to rearrange and actually use these to calculate lengths of triangles. So we are going to find the length of the side labelled x here. I'll just make sure we write that off so everyone can see. Alright. We're going to find the length of the side labelled x in this diagram. Step number 1. We label the sides. So if our right angle is here, our hypotenuse will be, yes, here. The opposite will be, think of where our known angle is, on the other side. Fantastic. And the adjacent is connecting to the known angle. So from what we can gather, x is the opposite. So we need to remember again, sok, ka, toa. So please keep that in mind. After we've successfully labelled the sides, the next thing I want you to do is we need to cross out one side that is not going to help us in our calculation so we don't get too confused. We have 6 centimetres of x here, hypotenuse and opposite. So those are the two lengths we want to know. So adjacent is deleted. We do this because either we don't know it or we don't need to know it. So make sure you cross out adjacent. We'll choose some SOHCAHTOA. If we have opposite and hypotenuse, which of those three will we be using? Yeah, sine. SOH is what we're focusing on. So ignore ka and toa. So we've got sine equals opposite over hypotenuse. I'll just give you all a bit to write that down. Fantastic. So, in the form of the triangle, which we have here for SOH, we want to find O. So cover it up, and we're left with sine times hypotenuse. See? So substituting in O will give us something. So if the sine of a known degree, which is 35, is equal to x over, what's the value for the hypotenuse? 6 centimetres. What can we do to find x? Exactly, we need to get rid of 6. We need to do what we do on one side, we need to do to the other. So the only way we can cancel 6 is to times it. So 6 times sine of 35 is equal to x. Please input that into your calculators, and once you've got an answer, please raise your hand to indicate that. Fantastic. And when we enter it, you should have a length of 3.4 centimetres. Now, to help you out, I've printed out this and we'll hand it out. Can you please page in your books for this step-by-step instruction on how we can actually calculate the length of a triangle. What I'd like for you all to do now is go to your activity sheet and begin working on these independently. I'll be walking around the room, as will Miss Alicia, and we'll be there to help you if you have any questions.
And now we've come to the second video in this three-part, which is providing feedback to samples of student work. This is all work will be related to the topic that was introduced in the instructional video, which is using trigonometry to find missing values that are the lengths of the sides of right-angled triangles. So for student sample 1, we have, this is quiz number 2 on sides. So question 1, find the value of k. And question 2 is find the value of x. So what the student has done in this scenario has used 40 degrees as their reference angle, and has actually made it adjacent over hypotenuse. But the thing is, the adjacent side to that angle would have to be j, and the hypotenuse is already clearly labelled, which is 8 meters. So already there comes into that frame of SOHCAHTOA. The first step is making sure in each problem is to make sure you label each of the sides of the right angle triangle. So for example, 8 meters is going to be the hypotenuse, and if you're using 40 degrees as your reference, that would make k the opposite in opposite if we were to pick the proper ratio. So what they've done, so they have shown me they're working out in that they've shown me which ratio they've picked. They've inputted the values. They've rearranged the equation so that k is found, so therefore they can use their calculator to find the value of k. But they have used the wrong ratio. Cos is adjacent over hypotenuse, when they need to make sure they are using sine. Because with cos, again, if you're using 40 degrees your reference, adjacent's going to be j, and h is going to be 8. But if we're trying to find the value of k, not j, then we would need to make sure we circle. So we would have to be k, which is opposite, over 8. And then input the values as this student has done, rearranged it as so, and the calculations would give us the actual value of the length. And now we come to sample 2. Now in sample 2, we seem to have also picked this. What's happened here is that the second student has also made that similar mistake in finding the value of k. So rather than focusing on that, as I've already explained in the previous video, we'll focus on finding the value of x. Now, in the first step is labeling the sides of the triangle, which hasn't happened. You've got x, which is the hypotenuse, given that's the longest length. You have 13 kilometers, and you have a reference angle of 55 degrees. So already the student has shown that due to the position of 13 and x, that 13 is what you would call the opposite side. So the ratio has been correctly picked, and that is sine theta opposite over hypotenuse. So they've picked the correct ratio. They've then inputted their values, and the student has actually shown it all coming together, and it's all working very well until you get to the third line, which is 13 times sine of 55 degrees equals x. Now this is where the main mistake that has happened, in that they have not actually arranged the equation appropriately. We must remember that the first thing we would need to do, we need to get x by itself. So if it's 13 divided by x, in order to get x onto this side, we need to times both sides by x, therefore cancelling it out. Then x is going to, then 13 is going to equal sine, then 13 is going to equal sine 55 degrees times x. So in order to make sure we remove it and get everything in the proper position so we can actually use our calculators to find x, sine would actually have to be, sine 55 degrees would have to be divided and removed from that side of the equation and put back on the other side. So it would actually be x over, it would be x equals 13 divided by sine 55. Apologies for the shabbiness of that handwriting, but that would be it. X equals 13 of sine of 55. Now in student sample 3, we have actually, the students have correctly labelled each side of the triangle for both finding the value of k and finding the value of x. There is O, A, and H on both, which stands for opposite, adjacent, and hypotenuse. In the second question, which is here, the student has correctly labelled each side, identified their reference angle of 55 degrees, and picked the proper trigonometric value ratio, which is sine theta. They have then put the values in each side, but have also made a similar mistake to student number 2 in the layout of rearranging their equations. So x is actually going to equal 13 divided by sine 55, not 13 times sine 55 degrees. So in this particular case, they have successfully labelled sides of the triangle. In question 2, they have found the correct ratio. They have laid out their workings and shown me what they actually did. And question 2, they have incorrectly rearranged the equation. So going forward, I think it'd be very important for them to remember the equation rules, in that what you do to one side must be done to the other. And I would also strongly recommend that they consistently refer back to the handout sheet which I provided them, which has the step-by-step process in using trigonometry and finding the missing values and lengths of right angle triangles. And now we come to video 3, which is adjustments for diverse learners. So during this, I usually do 2 things currently for adjustments for diverse learners. One is ensuring there's printouts of the PowerPoint slides in the event that a student's a bit too far away from the whiteboard and can't see the writing too much. And also just generally because a lot of the PowerPoints will contain formulas and step-by-step methods for solving mathematical problems. So that would be my first priority, ensuring that all students have access to that, to those, for ensuring that they're not, if they're visually impaired, for ensuring they can actually see what I am teaching and follow along as I give my instructions, and also so they have something they can refer to during their independent work. The other thing I do is using a different medium. In accordance with my school's Students with Additional Needs department, I have provided, in the event that a student has, for example, dyslexia or or another similar sort of disability, they are given a different medium. So usually this will be printed on blue paper, so the words are less jumbled. They can actually there's less confusion when reading a question for them. Those are the 2 main ones that I would employ. As for other suggestions, I think primarily when it comes to maths, I would probably, in reflection, that instruction lasted for approximately nearly 7 minutes. Probably interject with a check for understanding, follow along, maybe potentially break things down if it's required. Some students may be able to follow along at the pace that I'm given, and some might not be able to follow along. So I think it'd be very important to get the feedback from the students as you are instructing, to ensure that they can actually follow your direction and actually be able to keep up with the teacher's instructions. So there's less clarification seeking and less double checking with the teacher during the independent work phase of a lesson. I think potentially also looking at breaking things down even slower, and also explaining things potentially differently during independent work, perhaps going up to those particular students and discussing their issues they're having with their learning, and talking it through them, and hopefully presenting the work in such a way that they can actually follow along much more easily than they potentially would have during a whole class instruction. The school I'm currently at also employs mentors, so student mentors, to clarify, who operate basically as teachers' aides, but they have a particular student that they support, and that particular student has a education adjustment plan, or an EAP. So they have a registered diagnosis, or that basically makes them require additional needs in order to actually do the learning. So checking with the mentors at the start and during a lesson, perhaps even before a lesson, would be ideal, so that they can actually follow along and assist their allocated student if at a time that you are unavailable during the lesson.